Hello. Hello, everyone. Welcome to this presentation where we want to look at how best we can solve or how best we can determine the inverse of a 3 by 3 matrix using maybe a shortcut method, all right? Yeah, there are a lot of methods. You can use the cofactor, among other methods, but we want to see if we can come up with a shorter method. Okay, we want to see if we can come up with a shorter method. A method, maybe if we're able to solve it within seconds. Okay. So this is a 3 by 3 matrix. Yeah. So find the inverse of a matrix that we have here. Now, in order to find the inverse of A, we must first check if the inverse exists. So we'll check if the inverse exists if at all the determinant is non-zero. Okay. So the starting point is we check for the determinant of A. All right. What is the determinant of A? So to get the determinant of A, we'll eliminate the first row and the first column. Not necessarily eliminating. You pick this number, 7, using plus, minus, and plus. So it means I've got 7. So meaning that in this case, this is out and this is equally out. So we must find the determinant here by multiplying -5 by 8 minus 1 by -4, and this will give you -36. Okay. And the next sign is minus -6. So minus -6 to be just 6, open bracket. So in this case, we are removing this and the second column. So what do we have? 8 by 4 minus 2 by -4. And what does this give you? It gives you 40. So here you get 40. Then plus the last number here, 3. Okay. So in this case, if I'm using 3, where there is 3, it's the first row and the third column. We get rid of that. So 1, we multiply this. That will be 4 minus -10. So that one will give us 14. All right, give us 14. Now, I've decided to use the first row. If you want, you can use the second row or the third row. But if you use the second row, then we're going to have minus, plus, minus, plus, minus, plus. These are the signs that you are supposed to use. So when we work out this, when we compute, we get 30, which is not equal to 0. Hence, therefore, A inverse exists. Okay. A inverse exists. Now, how do we find the A inverse? So by definition, this is 1 divided by the determinant of A times the adjoint of A. Okay. So now, what is key here is to find the adjoint. If you want, you can go and get the cofactor matrix, so on and so forth. But here we're using a shortcut, what I call a shortcut method. So the first thing is, how do we get our adjoint? Okay, so we want to find the adjoint of A. So the first thing is to rewrite the whole matrix that we have been given. Okay, you rewrite it the way it is. So the matrix is 7. We have 7, 4, 2, -6, 5, negative 5, 1, 3, negative 4, and 8. Then you must repeat the first two columns. So there's 7, 4, 2, negative 6, negative 5, and 1. Then also, you must repeat the first two rows. The 7, negative 6, 3, 7, negative 6. Then you have got 4, negative 5, negative 4, 4, and negative 5. This is what we are going to deal with now. Okay. Now, from here, we must eliminate completely the first row and the first column. Therefore, I've got 1, 2, 3, 4. We're dealing with 4. A 4 by 4 matrix. In short, we are going to find now our adjoint from this matrix. Negative 6, 5. You don't need to rewrite. You can just go straight, but for someone to be able to follow nicely, let me rewrite it. So the first one is negative 5, 1, negative 6, negative 6, and negative 5. Then we have negative 4, 8, 3, negative 4. This is 4, 2, 7, and 4. Then we have negative 5, 1, negative 6, and negative 5. Okay. So we are going to work out the determinant on these two first. Okay. So when we work out that, so it will be 8 by this, that is the negative 40 minus 1 by negative 4. When you work it out, you are going to get negative 36. Now, we'll get this arrangement, which is in columns, but the answers will write them in rows. That is the only difference. Then you'll be done. Okay, so I'm done with that one, the first two. Then I deal with second and the third here. So you say 1 by 3 here minus negative 6 by 8. When you do that, you're going to get 51. Okay. Then I'll move to third and fourth, this. Okay. So when I multiply, you here, you have 24 minus negative 5 by 3. When you do that, you get 89. So I'm done with the first two. So now it will be the second column with the third column. Then the answers will be written in this manner. All right. So when I multiply this, so it's this that I'm dealing with first. When you multiply these with 8 minus open bracket 8 minus 4. So when you compute that, you're going to get negative 40. Okay. Okay. That's what you're supposed to have. So I'm just trying to verify the numbers. Okay, so here we check from the top here, -4. So this is -4. Because we have -8 minus 32. So this one will give us -40. Okay. So we have -40. Then we go to these two. Okay. So when you multiply this, when you multiply 8 by 7, then minus 6, you are going to get 50. Then we deal with the last part. This part. So I've got 12 minus 34 by 7, which is -28. So what are you going to have? You're going to have 40. Okay. This is what we are going to have. We're going to have 40. We're almost done. Okay. Then the last part, it will be this column now with that. Okay. Of course, we'll be pairing. All right. So now we deal with this. So 1 by 4, we get 4 minus, that's -10. What you're going to have is 14. All right. Then the other one now is 2176, -6. So when we work out this, that's -12 minus 7, we get -19. Then the last part now, -35 minus -24, will get -11. Then this one is your adjoint. You don't need to go very far. So our adjoint of A is that one. Meaning therefore that from the definition of the inverse, so our A inverse will be equal to 1 divided by 30 times the matrix that we have found. 36, -40, 14, 51, 50, -19, 39, 40, -11. And this is your answer. All right. If you want, you can multiply, you distribute. But that is our answer by definition. That's how you find your determinant. I mean, the inverse. Okay, thank you so much. Till next time. Bye-bye.